Hey, Mr. Harridan here. We're going to go over changing atomic structure. So we are going to be discussing the formation of isotopes. Okay? And to have the formation of isotopes, you have to have changing numbers of the number of neutrons. Okay? So the different number of neutrons causes isotopes. They're just heavier atoms. That's all there are. No chemical properties are changed, nothing like that. They just become, some of them become radioactive. Okay? But these have different mass numbers. Okay? You will see these used in hyphen notation here. So this is hyphen notation, this is the mass number. Okay? Carbon 12, carbon 13, and carbon 14 are the three isotopes of carbon. Okay? Carbon 14 is used to radioactively date how long stuff has been dead. Okay? Carbon 12 has 6 protons. Carbon 13 has 6 protons. Carbon 14, 6 protons. Carbon 12 only has 6 neutrons. Carbon 13 has 7 neutrons. And carbon 14 has 8 neutrons. Okay? So this is the definition of average atomic mass, also called atomic mass. It's the atomic mass given on the periodic table. This is the decimal number. Okay, of each element and its naturally occurring isotopes, and it's a weighted average. This is a big thing. It's a weighted average. It's not a real average. It's a weighted average. Kind of like how I figure out your grade. Okay, 40% are test, so I take your test average and multiply it by 0.4. 40% is quizzes, so I take your quiz average and multiply it by 0.4. Take your lab average, that's 20%. 0.2, multiply that by your average, and then I add them all together, and then I get your grade. Okay, so here is the formula for average atomic mass. Average atomic mass is equal to fraction of isotope number 1 times the mass of isotope number 1 plus the fraction of isotope number 2 plus the mass of number 2, so on and so on and so on. Okay? That is one equation we're going to have to know. Okay? There is also a fractional equation that you're going to see me use. The sum of percentages should be up to 100, so the sum of the fractions should be 1. So you're going to also see me use an equation fraction plus fraction equals 1 for when I do some wonderful algebra stuff. Okay? You want to use the exact masses. If not, you can just use the mass numbers. Okay. So here we go. Example 2.2. Naturally occurring chlorine is 75.53, chlorine 35, and 24.47, chlorine 37. What's the average atomic mass? So we're going to write down atomic mass equals mass times fraction, and yes, I expect you to write this down each time, plus mass times fraction. Okay? The atomic mass, that is what we're looking for. The first mass we're going to use is 35. So we're going to use 35. Okay. Now there are 2 ways to do the fraction here. I'm going to do the decimal way. You move this back 2 decimal places and it becomes 0.7553. Because decimals are just fancy fractions. Plus 37. And then I'm going to move this back 2 decimal places too, times 2447. And I am going to get the answer here. The atomic mass is equal to 35.49, according to my math. insert AMU. Record all atomic masses to hundredths place. Okay? That is what I expect you to do. Should I actually check the answer to see if I actually did it right instead of just trying to do it in my head? Because I thought I was going to get a different answer. Nope, I got 35.49. Should match what's on the periodic table, but it's close. Okay. The element of neon has 3 isotopes. Good for neon. Way to go, neon! You have 3 isotopes with the masses of 19.99, 20.99, and 21.99. These 3 isotopes have those percentages. Calculate the average atomic mass of neon. So this one has 3, so we got to do atomic mass equals mass times fraction plus mass times fraction plus mass times fraction. Okay, so here we go here. So this one they gave us the exact masses here, so we're going to do 19.99 times 0.9092 plus 20.99. Now we're moving this back 2 decimal places here, so it's actually, the fraction is actually 0.0025. That's where people go wrong, is they don't move their fractions right. And then this one is 21.99 times the fraction here of 0.0883, because that's actually 8%. We get an answer. Atomic mass is equal to 20.17 AMUs. Okay, now we get to the challenge problem. Of course, this has got to be a challenge problem there, Mr. Aaron. This is the challenge. Challenge accepted. Too bad I don't have my soundboard hooked up here. Okay. The element of silver contains 2 natural isotopes, 107 and 109. The accepted atomic mass for silver is 107.87. What are the percentages of abundance of 107 and 109? So this one, we're not looking for the average atomic mass. We're actually looking for the fractions here. So the equations we're going to use here is atomic mass equals mass times fraction plus mass times fraction. Okay? Now, the problem is we're looking for 2 percentages here. So we need a second equation here. So that's why we're going to use fraction plus fraction equals 1. Okay? Now you are going to see me substitute in my numbers here. The mass of silver is 107.87 equals mass of 107. The fraction I don't know, so I'm just going to call that x, plus 109. I don't know that one either, so that's going to be y. So this is going to be x plus y equals 1. Now, hopefully you can see that. What we have to do here is there's 2 methods to solve this problem. There's actually 3, but I'm only going to teach you 2. So we're going to do systems of equations here, so you can do substitution or elimination. I do elimination, so I am going to end up multiplying bottom by negative 107. So here what you're going to see me do. I'm going to rewrite the first equation here. 107.87 equals 107x plus 109y. I haven't done anything with that equation. Now I'm multiplying the bottom equation by negative 107. So this becomes negative 107 equals negative 107x minus 107y. So I've gotten my x's to cancel out here. So I am now left with 0.87 equals 2y. Love the bells. Y, it's been a while since I've had to say that, equals 0.435, because you end up dividing by negative 2, right? So y is equal to 43.5% of AG 109, which must bring up a question here. How do I know what x is? Well, the percents have to add up to 100. So I know x must be 56.5% of AG 107. Okay? Gonna do this a bunch of times, get a bunch of practice on it. Okay, you guys are champions. The legend is out.